Welcome to 8.2, Use Properties of Parallelograms. And our essential question is, how do I find angle and side measurements in parallelograms? So we're going to use these properties of parallelograms to be able to find angle measures and side lengths within parallelograms. And there are three different properties that we need to focus on here, 1, 2, and 3. Let me just, well, first of all, let's make sure you understand, and I'm sure you do, what a parallelogram is. First of all, we know that it's a quadrilateral. Quad means 4, lateral means side, so this dude has 4 sides to it. Oftentimes they'll write out parallelogram, PQRS, but sometimes they'll use this little symbol that looks like a parallelogram. So when you see that symbol, you know to say parallelogram PQRS, like this dude here. So what is it that makes a parallelogram? Well, it's when both pairs of opposite sides are parallel. So what does the word opposite mean? It means across from each other. And that's in contrast to adjacent sides. These two sides are adjacent, they're beside each other, as opposed to opposite are on different sides of the parallelogram. Okay, so in order to be a parallelogram, the opposite sides must be parallel. Or if they tell you that the opposite sides are parallel, then it is a parallelogram. So these two sides, of course, are parallel, and these two sides are parallel. And even if we were told nothing about this deal, just looking at these designations here, we have single arrowheads here, tells us these two are parallel. We have double arrowheads, tells us that these two are parallel, and we know for sure now that this is a parallelogram. Okay, now knowing that it's a parallelogram, what else do we know about it? Well, here's some theorems, 3 different theorems that we know, characteristics, properties about parallelograms that will always be true once we know that it's a parallelogram. First one is, and let me remind you about how a conditional statement works. We have the if, hypothesis, then conclusion. Remember that from chapter 2? This is a conditional statement. If hypothesis, in other words, whatever that follows the if part, the clause here, that's the hypothesis. And then whatever follows the then, that's the conclusion. If hypothesis, then conclusion. And specifically, if a quadrilateral is a parallelogram, then its opposite sides are congruent. Opposite sides. Okay, these two sides are opposite, so they are congruent, is what this theorem is saying. And same thing here, these two are opposite, and therefore they are congruent. What this is just the same statement, just written with symbols. So if PQRS is a parallelogram, or symbols, and also in this specific example, then these two segments or sides are congruent, and also these two sides are congruent. Okay, so it's the same thing, just said more specifically, and also with symbols. So the theorem again, saying if we know it's a parallelogram, then we know that the opposite sides are congruent. The converse is also true. So what does converse mean? We're talking about a conditional statement, if hypothesis, then conclusion. Converse, remember, that's switching. So we can, instead of saying if we know it's a parallelogram, then we know that the opposite sides are congruent, we can take the converse of that, and that's also true, that if the opposite sides are congruent, then we know that it is a parallelogram. Okay, so that's the first property. Here's the second one, that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So first we talked about opposite sides being congruent. Now we're looking at opposite angles being congruent. So what they're telling us is that if it is a parallelogram, then the opposite sides, no, not sides, the opposite angles. The opposite angles are going to be congruent. And so these two angles are congruent, opposites of each other, so therefore they are congruent. And the converse of this theorem is also true, that if we can prove that the opposite angles are congruent, then we know that this guy here is a parallelogram. Okay, so those are our two theorems. Let's put those doggies to use and to work. Here's example number 1 out of your textbook, and they want us to find the value of x. So let's do that. Well, it looks to me like this is a parallelogram, and how do I know that? How is it that I am so smart to be able to figure this out that this is a parallelogram? Well, because I have individual arrowheads here, so these two are parallel, and I have double arrowheads here, so these two are parallel. So therefore this dude is, or maybe it's a dudette, I'm not sure, is a parallelogram. And knowing that it's a parallelogram tells us that the opposite sides are congruent. So we know that this length is equal to this length. And so therefore we can set these guys equal to each other. So x plus 4 equals 12. And then I can solve this algebraic equation for x. And I get x equals 8. And I could plug that in here for x. And x plus, or 8 plus 4 is 12. Okay, hey, so they both have the same length. So our answer is x equals 8. They also want us to find the value of y. Knowing that this is a parallelogram, not only are the opposite sides congruent, but also the opposite angles are congruent. And so if this dude over here is 65, then the other one, the opposite angle, is also going to be 65 degrees. That wasn't too hard, was it? In fact, you might even say it was easy. I don't think you'd say it was fun, but you can say it's easy. So now you're ready to do these two here on your paper. And so first of all, confirm that this is a parallelogram. Just don't jump in there and start throwing things around, but make sure you know what you're dealing with. Quadrilateral, parallelogram, yep. And so they want us to find, remember FG is the length of FG, so here it is. Here's FG, so I want to know the length of this guy. How do I figure that out? Well, the opposite side is 8, so therefore what is the value of FG going to be? So make sure you write that down there. And how do I figure out what the measure of angle G is going to be? Hey, it's the opposite angle from this dude over here, so that's pretty simple. And go ahead and do the same thing over here, but you're going to have to create an equation here. So 18 equals y plus 3, and solve that for y, and then create an equation here. Okay, so remember, when the number or value is, or expression is inside of the angle, that's the measure of an angle. And then when it's outside, that's the length of a side. Okay, so go ahead and stop the video and do those two there. So remember I told you that we have 3 properties. The first one was about the sides in a parallelogram. In a parallelogram, the opposite sides are congruent, and also the opposite angles are congruent. The third property now tells us that consecutive angles are supplementary. So what does consecutive mean? Remember, consecutive is like consecutive numbers are 1, 2, 3, 4. So consecutive would be alongside of each other, or that's not a good way, because remember, adjacent is beside each other. Consecutive would be the next in line. I like that. The next in line. So x and y here is an example of consecutive angles, or x and y here, or y and x here, or x and y there. Okay, so there's 4 different pairs of consecutive angles there. And they're telling us that in a parallelogram, the consecutive angles will always be supplementary. What does supplementary mean? it means they add up to 180 degrees. So where did they come up with that? Well, you know that. Come on. Just think of this side as a transversal. All right, it's cutting across these other two lines. And so what is the relationship between these two angles? Well, here's your transversal. Are they alternate sides of the transversal or same side? Yeah, they're same side. So on the same side of the transversal. And now are they interior or are they exterior? And they're both interior. So these two angles are same side interior angles that are created by a transversal across two lines. And what do we know about those two lines? Well, we're told that this dude is a parallelogram. So therefore these two lines are parallel. And whenever same side interior angles are created by a transversal across two parallel lines, then we learned, what chapter was that? Chapter 3? That these angles will be supplementary. So they add up to 180 degrees. Okay, so let's do an example. Here is, let me get my little stand, lift this up, make it closer to you. Okay, here is a desk lamp. I'm sure you have a lamp like this in your office, at your desk somewhere in your house. And did you know, almost always, that these guys are parallelograms? And that is the case if these two opposite sides are congruent. Remember, like we said here, if the two opposite sides are congruent, then it is a parallelogram. And so it's almost always the case with these lamps that these opposite sides are congruent with each other, and therefore no matter how you bend this lamp around, these two sides will always, the opposite sides will always be parallel, and these other opposite sides will also be parallel. And so they are telling us, what I did was I took this and I blew it up, kaboom, made it into this nice little diagram, a little bit easier to see. And they're telling us that the measure of this angle ADC is 110 degrees. So I know this angle is 110 degrees, and they want us to find the other angles. Well, what was the thing we just learned? We just learned that consecutive angles in a parallelogram are supplementary. Okay, so here's consecutive angles, a pair of consecutive angles. So if they're supplementary, it means they add up to 180. So really what I probably should have done is to say 110 plus, and let's call this A, right? 110 plus A equals 180. That didn't leave myself very much room there. And then I subtract 110 from both sides, and that's what I'm doing here. Take 180 minus 110, and I get 70. So this angle over here is going to be 70 degrees because they're supplementary. They add up to 110. And hey, here's another pair of supplementary angles. And so what's the measure of angle B going to be? What's B going to be? So I would say, what would I do here? I'd say 70 plus B equals 180, right? Yep, 70 plus B equals 180. So I subtract 70 from both sides, and I would get B equals 110. That's interesting. Oops, not 100, 110. So that's interesting. Hey, that's the same number as this over here. And why is that? Hey, we already knew that. Because opposite angles of a parallelogram are always congruent. And if we were to, here's another consecutive pair of angles. And so therefore they're supplementary, and so therefore this is going to be 70 also. Notice how that works. So opposite angles are congruent, and consecutive angles are supplementary. And, well, you know what? I said there were 3 different properties, but actually there's 4, aren't there? I should have summarized this better. Okay, so diagonals. Not only are we learning about that opposite sides are congruent and opposite angles are congruent and consecutive angles are supplementary, we are also learning that diagonals, here we go, diagonals bisect each other. Diagonals are bisecting each other. So there's 4 different properties here. So what does it mean? Well, first of all, what are diagonals? Remember, they go from one vertex to another vertex, not a consecutive vertex, but another vertex. So here's one diagonal, and here's another diagonal. There's only two diagonals in a parallelogram. And they are telling us that these diagonals bisect each other. And so therefore, what do I want to do? Let me do a black. No, that's too dark. Let me get a all right, thank you for your patience. Here we go. And let me put a big M here. So what does it mean to bisect each other? It means that this point of intersection is a midpoint not only on this one here, but also on the other diagonal. Okay, let's get this video done, huh? So we have these four. We have these four properties, and let me give you another example from the book on how to do this. Let me give you my little stand here. So they're telling us that, see here, that's the symbol for parallelogram. So parallelogram, LMNO. So this guy is a parallelogram. They are telling us, and actually we could confirm that, couldn't we? Because look, of course these two are horizontal, so those have the same slope. And then what's the slope of this guy? It's a rise of 1, 2, 3, 4, and a run of 1. So 4 over 1 is the slope for this left side. So what's the slope for the right side? 1, 2, 3, 4 over 1. Hey, these two have the same slope, therefore they are a parallelogram. So we didn't even need to know. They didn't have to tell us that this was a parallelogram. In fact, do they? No. Well, they do here, yeah. They didn't need to tell us that it's a parallelogram. We could have determined and proven that it is a parallelogram. But now they're asking us to figure out the coordinates for this point P, the point of intersection of these two diagonals. That's interesting. How do I do that? Well, remember they bisect each other. So therefore, this is the midpoint of this segment. It's also the midpoint of this other segment. So how do I find the midpoint between these 2 points, MO, or I could use these 2 points of LN? And you'll remember, this is the midpoint formula. When you think of midpoint, of course you think of middle, but you should also think of average. You take the average of the x coordinates, so you add the x coordinates and divide it by 2, and then big fat comma there. This is the x coordinate, or this is the x coordinate of the midpoint, and this is the y coordinate of the midpoint. So add the y coordinates and divide by 2. Okay, so that's all they're doing with the rest of it. That's simple enough for you. You should be able to do that. So I didn't look at this, so you can figure this out, right? Finally indicated, that's a parallelogram in M. Hey, what does that mean? When it just has 2 letters like that, what does that mean? Remember, it's the length of segment in M. So in M. So you want to find the length of this guy. This 2 refers to what? It refers to the length of this guy. So that should be pretty simple for you. Tell you what, I'm going to let you figure that out on your own. Find for yourself. Okay? Hope that was helpful. May the Lord bless you. And I do look forward to seeing you in class.